Now that we've learned about degrees and radians, let's learn about how to easily convert them. Now, we know the unit circle in radians, we know the unit circle in degrees, but what if you just need to do a quick conversion? Well, we can actually learn that pretty easily. So this lesson is converting from degrees to radians. Remember that we make the radius of the unit circle 1, right? So the circumference is equal to 2 pi radians, or just 2 pi if they say r equals 1. Means half the circle is 1 pi radian. So half of this is pi. So the easiest way to think about this, since 2 pi equals 360 and you divide by 2, you get pi equals 180. And if you divide both sides by 180 degrees, that means that pi radians over 180 equals 1. So what that means is you can multiply a degree by pi over 180, pi radians over 180 degrees, and you're really just multiplying it by 1, because there are pi radians in 180 degrees, no matter what. That's what we're going to be doing in this lesson. If you have a degree and you want to go to radians, you multiply by pi radians over 180. And a lot of times we don't put the r, we assume it. By pi over 180, we mean pi radians over 180. So that's all you have to do. Let's get to it. Let's say you had 255 degrees and you were trying to convert to radians. Let's put a little degree mark up here. All right, so how many radians is that? Well, you're going to multiply by pi over 180. That's it. And what's going to happen is every time you're going to be cross-canceling from top left to bottom right. The biggest number that goes into 255 and 180 is 5. So I'm going to divide the top and bottom by 5. 250 over 5 equals 51. 180 over 5 equals 36. Now, sometimes you'll do this like I did in this example, and I notice, oh, wait a minute, 5 isn't the biggest number that goes into it, because these can be divided again. So 51 divided by 3, 36 divided by 3, I need to do because 3 goes into both of these, and now I get 17 over 12. Your final answer is going to be something pi over something else, or it might not be anything, but over anything, but you will have pi in your answer because you're going from degrees to radians. Now, since we did mention that 15 was the GCF, we might as well just show it that way as well. Okay, so let's suppose we noticed that 15 was the biggest number that went into them, then we could have automatically just divided both by 15. But it's the same as dividing by 5 and then dividing by 3 again, right? So in either case, we still get 17 pi over 12. And again, if you want to, you can write r radians, and that's equivalent to 255 degrees. So multiply by pi over 180 and then simplify. The top of your fraction will always contain pi. Let's do another example. All right, let's do 120 degrees. Well, if you multiply that by pi over 180, you'll cross cancel the 120 and the 180. Biggest number that goes into both of those is 60. Okay, so I can jump straight down. 120 over 60 is 2 pi. 180 over 60 is 3. Answer is 2 pi over 3. Okay, another way to do it, divide by 10 and then divide by 6. Same thing as dividing by 60. Final answer, 120 degrees is the same as 2 pi over 3 radians. Excuse me. We can pull up our unit circle here. There's 2 pi over 3. If we go back to degrees, we can see it's the same as 120. Bounce back and forth very quickly to see how they are equivalent. So the more you play around with this, the more you'll see how radians and degrees interact with one another and how they're pretty much the same thing, just talking about it in a different way. Let's say we want to do 405 degrees. Well, multiply it by pi over 180. We'll do it the long way this time. And you can immediately tell 5 goes into both of them, so divide both by 5. 405 over 5 is 81. 180 over 5 is 36. And then divide by 9 from there, because 9 goes in 81 and 36. Final answer is 9 pi over 4 radians. Now, this is not a standard angle, but it is equivalent to 405. So the point of this example is it doesn't have to be between 0 and 360 in order to convert. If you notice, you could have just divided top and bottom by 45, and you still would have got 9 pi over 4 radians. How about negative 15? Well, yes, you can do negatives as well. Still multiply by pi radians over 180. Again, if you want to, you can put the r in there in your final answer because your units are radians. DCF of these two is 15. So divide both by 15, you get negative 1 pi over 12, which simplifies to negative pi over 12. It means that negative 15 degrees is the same as negative pi over 12. And yes, I do have the unit circle with multiples of 15. So negative pi over 12 is actually the same as 345, all right? Which is the same as, let's see what that is, 23 pi over 12. So we'll get to more of that later. You can see this is positive pi over 12, so naturally negative pi over 12 would be the same, but in the other direction. How about 225? Multiply by pi over 180. DCF is 45. So divide top and bottom by 45, and we get 5 pi over 4 radians. Which again, if we bring back our unit circle up, we can see 5 pi over 4. There it is, 225 degrees. One more, 180. Well, if you multiply pi by pi over 180, obviously the 180s are going to cancel and we're going to end up with pi. Again, that is kind of our benchmark. That's how we relate degrees to radians easily. There are pi radians in 180 degrees. We can see that on our unit circle app. Pi is the same thing as 180 degrees. All right. If you have any other questions about this lesson, converting from degrees to radians, let me know.